Hello, everybody. So hopefully you're doing well this morning. I know it's a little tough to be back in the swing of things here, but we'll get at it. So what we're going to be talking about today is we're going to be discussing what are called conjugate pairs and why that's important to what we're studying, which is breaking these polynomial functions down. So in a nutshell, what a conjugate pair is they are pairs of complex numbers. So if you recall in the last one of the last problems that we did in yesterday's video, we come up with a couple of imaginary solutions. In this one, for instance, this first one, you can see this x plus 3 right here. This x plus 3, I'll get my pen to work. This x plus 3, when we set that equal to 0, we ended up getting imaginary solutions. Now, when that happens, we never, ever, ever get imaginary or complex solutions. We never get one by itself. They always have to come in pairs. So those are called conjugate pairs. Now we can use that fact to help us then either break down these big polynomials or and you'll see in this case today, to actually create a polynomial, knowing that complex and imaginary zeros always come in conjugate pairs. So in this first example, it says find a fourth degree polynomial. So if you remember also from yesterday, if it's a fourth degree, that means the highest power is going to be 4. There needs to be 4 zeros. There will be 4 zeros. Now, it doesn't mean they're all real. Some of them will be imaginary, but there will be 4 zeros. And in this case, you can see they gave us the zeros. They told us that -1 or -1 is a 0. They also told us that -1 is another 0. Remember, the word from yesterday is called multiplicity. So it's actually 1 0, but it's listed twice, so its multiplicity is 2. They also told us that 3i is a 0. Well, according to this conjugate pairs that I was just talking about, if you have positive 3i as a 0, you also have to have negative 3i as a 0 because they always come in pairs. Now, that should make sense also because now look, we have 1, 2, 3, 4 total zeros. It's going to be a fourth degree polynomial. You have to have the same number of zeros as you have powers. And so what do we do with this information? They want us to write a polynomial with these as the zeros. Well, recall that we know that a factor is going to be x minus the 0. So in this case, we can write all 4 factors. It's going to be x minus -1. Then we're going to write another one of those. And then we're going to write x minus 3i. And then I'm going to write x minus -3i. So I've set up all the factors now based on the facts that x minus 0 is a factor. You can see there's 4 of them, as there should be, because it's a fourth degree. I'm going to clean this up a little bit. It becomes x plus 1. This one becomes x plus 1. The next one stays x minus 3i, and then the last one becomes x plus 3i. Now, I'm going to give you a helpful hint. When you have complex or imaginary zeros mixed in with real zeros, you always want to multiply the real ones together first and the imaginary together first. And you're going to see why here in a second with the imaginary. But let's FOIL out the x plus 1 times x plus 1. That equals x squared plus 2x plus 1. I'm going to put a set of parentheses around that. Remember, first, outer, inner, last. I'm going to kind of go over that a little quicker than I normally would because at this point you guys should be good at foiling. Now, the next one, though, I am going to write out. So we're going to do x times x, which gives me x squared. Then I'm going to do x times 3i, which gives me 3ix. Then I'm going to do negative 3i times x, which is negative 3ix. Then I'm going to do negative 3i times positive 3i. Now remember, negative 3 times positive 3 is negative 9, and then I times I becomes I squared. Now there's something that you need to remember about I squared. I squared is equal to -1. So anytime you have an I squared, you can substitute and should substitute a -1 in for that. So also look at these center terms. You have a positive 3ix and a negative 3ix. So these cancel. This I squared is going to become -1. That -1 is going to multiply the -9 and just become +9. So what we're going to be left with is x squared plus 2x plus 1. Then we're going to have x squared plus 9. And as you can see, what ended up happening was the imaginary terms all went away. That should happen when you multiply conjugates together. And that's really important. That's why I said you FOIL those together first, because all the imaginary numbers should cancel themselves out or turn into -1, and then you won't be there anymore. Now, the last thing we have to do is to FOIL these two terms together to get our last polynomial. So we're going to do x squared times x squared, then x squared times 9. So that gives me x to the 4th plus 9x squared. Now I'm going to do 2x times x squared, which is 2x to the 3rd. Then I'm going to do 2x times 9, which gives me 18x. Then I'm going to do 1 times x squared, which is x squared. And then I'm going to do 1 times 9, which is 9. So now we've FOILed that together. We need to double check, are there any like terms? It looks like there's 2x squared terms there. So the final answer here then is x to the 4th plus 2x to the 3rd, and then plus 10x squared. So we use the x to the 4th, x to the 3rd, we use the x squareds. We're going to write the x, which is plus 18x, and then plus 9. And there you go. There is our 4th degree polynomial that we got by multiplying all of the factors out. Now, this talks about the linear factorization theorem, and basically all that tells you is exactly what I have already said in the previous video, is that if you have a 4th degree, there's going to be 4 linear factors. Now, that means, though, some of them might not be real factors. There might be imaginary ones. And you can't have a quadratic equation that is irreducible over the reals, like I've shown you. So in that case, I'm going to give you this polynomial here. So we have an x to the 4th minus 3x cubed plus 6x squared plus 2x minus 60. And we want to find all the zeros, the real and the imaginary. So we need to begin to break this, we need to break this polynomial down. Now, according to the last video, you would have to do the P over Q, right? We don't have any other way. There's 5 terms, so you can't do it by grouping. But they did us a favor and they told us one of the zeros. That's really important. They told us that 1 plus 3i is a 0. Now, because we know that's a 0, we should be able to factor that out and then make this a smaller polynomial that we can continue to break down further. Now, because 1 plus 3i is a 0, that means 1 minus 3i is also a 0 because they always come in conjugate pairs. So what we want to do first is we want to get rid of these imaginaries. We want to turn them into a real polynomial. So we're going to set up our factors. It's going to be x minus 1 plus 3i. And then it's going to be x minus 1 minus 3i, like that. Okay? And now we're going to have to FOIL this together. Now, this gets a little bit complicated. There's a lot of room to make mistakes here. So you got to really be careful what you're multiplying. We're going to do x times x, which is x squared. Then we're going to do x times negative 1 minus 3i. So it's negative x 1 minus 3i. I'm not multiplying that out yet. I'm just doing x times negative 1 minus 3i. Now I'm going to take this negative 1 minus 3i. I'm going to multiply x right there. So it's negative x 1 plus 3i. And then I'm going to take this negative and it's going to multiply this whole thing. So then it's going to be negative times a negative is a positive 1 plus 3i, 1 minus 3i, just like that. Okay, now I'm going to further multiply this out. I don't try to do too much multiplication at once. So this negative x is going to multiply here and here. This negative x is going to multiply into here and here. Then I'm going to FOIL this out. So I get 1, and then I get minus 3i. Then I get plus 3i. And then right there, I get minus 9i squared. And now the last thing to do is to clean this whole mess up. So that's the worst part, is getting all the foiling. So we need to find all the like terms. I can see a plus 3ix minus 3ix. And then I see a minus 3i and a plus 3i. And then right here, this I squared is going to turn into negative 1. It's going to multiply that negative 9. So what I'm left with, there's an x right here and a minus x right there. So I'm left with x squared minus 2x. So I use the x squared, then the minus 2x. Then I have this 1 right here. And then this negative 9 times negative 1 turns into positive 9. So I get x squared minus 2x plus 10. So by foiling, by taking the zeros that they gave us, writing the factors right here, and then foiling the factors together, we get a new polynomial, x squared minus 2x plus 10. Now, what are we going to do with that? Well, we are going to divide that out of the original polynomial, because remember, we're trying to break that polynomial down, but we can't do division with imaginary zeros. So we needed to FOIL them together, the conjugate pairs together, and get this, and then we're going to divide that out of the original thing. Now the problem is, though, we can't do synthetic division with an x squared term. You're limited to only doing synthetic division with linear terms. So I'm going to have to do long division in this case in order to get this to work. So I'm going to write x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. All of that is going to get divided by x squared minus 2x plus 10. So this is one of those cases where we have to use long division. So x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x to the third. X squared times 10 is positive 10x squared. Those all are going to get subtracted. You can see the x to the fourths cancel. Remember, when you do division, long division, that's supposed to happen. If you don't have that first term cancel, you didn't do something right. We have negative 3x cubed minus negative, so it's going to become negative x cubed. Then we have 6x squared minus 10x squared becomes negative 4x squared. Now we're going to drop the 2x. And then we're going to do the whole thing over again. So I'm going to multiply by a negative x. Negative x times x squared is negative x to the third. Negative x times negative 2x is positive 2x squared. Negative x times 10 is negative 10x. I'm going to subtract. You can see this first term cancels. This becomes negative 4 minus 2 is negative 6x squared. 2 minus negative 10 becomes 12x, and then we're going to drop down the minus 60. Then we're going to multiply by negative 6 right here. Negative 6 times x squared is negative 6x squared. Negative 6 times negative 2x is 12x. And then negative 6 times 10 is negative 60. Now remember, we were told originally that this 1 plus 3i was a factor, and that means 1 minus 3i is a factor. So if we did everything right, what we came up with down here, this part I just put 2 stars beside, that should divide out evenly. And if you look, everything canceled at the bottom and we did not end up with a remainder. That's good. That means we've done everything correctly. So where are we? Well, what we have left, you can see once we divided out x squared minus 2x plus 10, we were left with x squared minus x minus 6. X squared minus x minus 6. Well, there are still two more zeros in there that we need to figure out what they are. Remember, this one right here, we already know what the zeros are. This one was formed by foiling those two zeros together. So we know the two zeros of that one. We got to find the other two zeros. How do we know there's four? Well, we know there's four because it's fourth degree. So right here, you can see I can just straight up factor this, x minus 3, x plus 2, like that. So x minus 3 equals 0, x plus 2 equals 0, and there are the other two zeros. And they are real zeros, which means the graph will cross at 3 and negative 2. So let's kind of take a recap of what we did in this problem. We were given two imaginary zeros. So we were given one, we had to come up with the other one because it's a conjugate pair. Then we wrote the factors and we foiled them together to get this new polynomial. Once we got that polynomial, we divided it out of the original one. And with what we had left right up there, we then set that equal to 0 and solved it to find the other two zeros. So this is kind of like a puzzle in that they're going to give you some information. Your job is to break this polynomial down and find all the zeros that you possibly can and find the factors. Okay, guys, that's what I have for you today. As always, if you have any questions, feel free to email me. Have a great day.